Welcome back to your favorite intermediate algebra course. Good to see you guys. Today's topic is finding rational zeros, and I just listed the rational zero theorem here, which shows that if you have this polynomial, f of x equals a to the n, x to the n, plus blah 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 down to your constant a sub 0, if it has integer coefficients, okay, each of the coefficients must be integers, then every rational zero, note this is not every zero, but each rational zero must have this form, p over q. P is your factors of this constant term. Here's your constant term, a sub 0, all over the factors of this leading coefficient, a sub n, right there. Okay? So, let me blow this up a little bit. Let's do an example. Let's say we have, let's go ahead and list and then find all the rational zeros of about that function right there, x cubed 5x squared plus 2x minus 8, okay? First, let's list them. Let's list the possible rational zeros. Possible rational zeros. And remember, zeros are x-intercepts. So the question is, where am I hitting, right? Am I hitting there at 2? Or maybe I'm hitting at 4? You know, where? Maybe I'm at negative 2/3, right? Where are these possible zeros? And then we'll go ahead and we'll find the exact zeros, the exact x-intercepts, okay? So the possible zeros are of the form p over q, where we have p is the factors of this number, our constant, negative 8. So you're thinking about all the factors of 8. Yeah, you could have 8 and 1, right? You could have 4 and 2, right? But you could also have negative 8 and 1, right? Again, it's a negative 8, so it should be either 8 times negative 1 is negative 8 or negative 8 times 1. In other words, you have both of these on this. You have to consider both situations. You could have 4 and negative 2, or you could have negative 4 and 2. So you got to consider both scenarios there, okay? So the factors on the top are going to be plus minus 8 over, and then we're going to think about the factors for the leading coefficient. Well, what's the leading coefficient that I'm going to draw here in red? Leading coefficient's 1. So the only factors are 1 and 1, right? So plus minus 1. 1 times 1 is 1, right? So you have plus minus 8, and you're going to take each of these factors of the constant over factors of the leading coefficient. So plus minus 1 over 8, comma, you could have plus minus, let's go with the 4 over 1, plus minus 2 over 1, and finally plus minus the 1 over 1, right? So we take each of the factors of 8 and we put them over the factors of that leading coefficient. So here's all our options, okay? So on the graph, we could be hitting out here at 8. Maybe we're hitting at negative 8. Maybe we're hitting at 4. Maybe it's negative 4. Maybe we're hitting at 2, negative 2. Maybe we're hitting at 1 or negative 1. We don't know. We do know, and I'm going to talk about this in a little bit more, there's something called the fundamental theorem of algebra, and I'm just going to say something about it right now. You have, at most, 3. You have at most 3 zeros or 3 x-intercepts, okay? So we're going to be able to find those, and we're going to look for, right now we're just going to look for the real zeros, okay? So let's go ahead and, oops, erase that for a minute there. Okay, so the question is, how do we find if they are a zero? Because we got to test each one of these so that we can break this function down, break it down into its factors, okay? So we test them one by one. Well, there's a couple ways you can test them. You can either use the remainder theorem. The remainder says if f of k is 0, right? So if I plug a k in, my remainder is 0, well, guess what? That's a 0. Okay, in other words, it's an x-intercept. For instance, if I plug in, let's say I plug in, oh, I don't know, negative 1. We try negative 1 first. If it pops out 0, I know it hits right there. I know it's a 0. which means it's also a factor, okay? Now, the other way to test it is just to see if I get a remainder that's 0. Okay, so I use synthetic division to do it. So I use my k to be -1. Okay, so my k is -1, and then I go ahead and I do the division. So what I'm doing now, okay, is I'm trying to break this down. Okay, my f of x, trying to break this thing down by factoring it. Okay, but again, I can't factor this x cubed because I need to know where to start. In other words, what's one of my factors? What's one of my factors so that I can start breaking this thing down and get it to a quadratic so I can finish it off, okay? So I say, well, let me try this k being -1, and if I get a remainder that's 0, I know that x minus that number, in this case, if -1 works and it has a remainder that's 0, I know x minus -1, in other words, x plus 1, I know that will be a factor. Okay, if it doesn't work, I throw it out and I try the next number. I try the next possible rational 0. Okay, so I'm trying 1, the right-hand side of this list here. Or I'm sorry, -1. Trying -1 first. Okay, so let's look at these coefficients of f of x equals x cubed plus 5x squared plus 2x minus 8. So we got 1, 1, 5, 2, -8. Okay, and we're hoping for a remainder that's 0, right? If I have a remainder that's 0, I know it's a factor. Okay, so I bring that down, 1, -1. Nope, didn't work, right? Didn't work. So I know x minus -1, that is not a factor. That is not a factor. Okay, it's not, and graphically speaking, -1 is not an x-intercept. At -1, I do not cross the x-axis. Okay, so we've tried 1. I could throw it out, right? Let's throw that one out. Let's try -1 now. How about -1? Does that work? I do the division again. Again, I'm hoping that I get 0, right? Bring it down. -1, 4, -4, -2, 2. Oh, I'm sorry. I just did -1. Hee hee. Just kidding. I'm trying +1. Let's do that again. Ah, sorry about that. Okay, try +1. Hey, there we go. It does work. Okay? So I say, yes, I have a remainder. That means x minus k, 1, x minus 1 must be a factor. Graphically, I must, that original x cubed plus 5x squared plus 2x minus 8 crosses right there at 1. It hits that x-intercept, okay? So I know it's a factor. Now that I know it's a factor, guess what I do with this? I put my answer right here. So 1x squared plus 6x plus 8. And now it's a quadratic, so I can finish factoring this thing. Okay, that's going to factor in x plus 2, x plus 4. And guess what? I can find all my zeros. In other words, my x-intercepts. Because when an x-intercept, to find an x-intercept, remember how you let f of x be 0? Or y value be 0? So I have an x-intercept at 1. We already knew that. At -2 and at -4. Okay? So you hit at -2, and guess where else you hit? You hit at -4. Okay? And just to throw in a little bit more, you know the end behavior of this thing is going to go down to the left, up to the right, correct? We talked about the end behavior, so it's probably doing something like that. Who knows exactly? You know, we could put in some more points and graph that, put them into the original cubic function there. But now we kind of have a feel for that, all right? So the first thing you want to do, list the possible zeros. Number 2, you want to test them, and I like to test them using synthetic division. And as soon as you find one that has a remainder that's 0, you see that right there? You say, oh, x minus k, x minus 1, x minus that number is a factor, right? So we say, okay, x minus the number is a factor. And now I also, and this is another reason I use synthetic division, because it pops this piece out right there for you, okay? You don't have to go back and do a division or maybe polynomial long division or whatever. You don't have to take an extra step, if you will. So you have 1x squared plus 6x plus 8, right? And then you factor this further. And luckily, this is a quadratic, so I could just go ahead and factor that one, okay? So that's your approach to this, to that problem, to find, to list and then find all the rational zeros, okay? So let's let me do some more here. Let me. Okay, let's say. Let's look at. There's a great problem in your notes here. Let's look at. Let's find all the zeros of. Okay, let's do this one. Okay, number one. Let's list all the possible zeros, all the possible rational zeros, right? These are only rational zeros. So I say, okay, factors of 6 over, guess what else we got? We got factors of 6 over here, don't we? So we could have 6 and 1, 3 and 2, right? Plus or minus on each of those. Same thing over here, 6 and 1, 3 and 2, okay? So we say, okay, plus, minus, let's go 6 over, and let's do the 6 right there first, 6. And then let's go to the next one, another possible. Let's go with the 1 over, and I'm going to continue to do it over 6. Plus minus, and let's go 3 over the 6. Let's go plus minus 2 now over the 6. Okay, we got to keep going. Now I'm going to use, how about the 1? Let's use the 1 on the bottom, okay? Plus minus 6 over 1, plus minus 1 over 1, plus minus 3 over 1, plus minus 2 over 1. I keep going. Plus minus, let's go now to, let's use the 3. Oh, I'm sorry. The 3 here, 3 right there. So I go 6 over that 3, 6 over 3. Now I go to my next one, 1. And I'm using the 3 again on the left hand there. Plus minus the 3 over 3, plus minus 2 over 3. Again, it's factors of this one over factors of that one, right? It's just they both happen to be 6s here. Okay, finally, let's see if I use red. Yes, I got blue. Plus minus. Now I'm going to use, see my 2, I'm going to use my 2 on the bottom every time now. So 6 over 2, 1 over 2, 3 over 2, and 2 over 2, okay? Now I want to avoid any repeats, right? You notice like 6 over 6 is 1, right? Well, we already have a 1 listed right there, plus and minus 1. There's another 1 right there. There's another 1. Don't want to have any repeats. 3, 6, we should have 1/2 already listed. 3, 6, see the 1/2 already listed right there, okay? 6 over 3, we already have 2 listed, okay? See the 2 already listed right there. 6 over 2, we already have 3 plus and minus 3 already listed. 2, 6, we already got 1/3 happens to already be listed. Okay, so it looks like we got 1/6, 6, 3 plus minus 1 plus minus 3 plus minus 2, 1/3, 2/3, 1/2, and 3/2. I think that's all of them. Do you see how many there are, right? A ton of them there. Okay, how annoying is that? Hold on, I'm going to stop right there. I'm going to do the next video, and we're going to look now graphically at this, because you could be testing this thing forever, right? So hold on for a sec.